Hi, let's learn about ArcFunctions today. First, let's think about the regular sine function. If I had the regular sine function, I know that my input would be any angle, and my output would be the trig ratio. If I am doing the arc function, we're just going to switch those two. So if I'm doing the arc sine of x, the input is going to be the trig ratio, and the output is going to be an angle. The only thing that we have to think about is that functions only have out one value, and so we are going to have the restricted range for the angles. Let's see how we come up with these. First, let's go ahead and graph the basic sine function, which you've learned earlier. Now we're going to restrict the region so that the sine can have an inverse function. We do that by selecting a section of the sine function that will pass the horizontal line test. So by definition, this is always true. This is our definition. We are going to make the restriction between negative pi over 2 and positive pi over 2. Let's look at a couple key values. This value right here is pi over 2 is x, and the y value is 1. Let's pick another value. And I always like to pick this value, pi over 6 for x, and that gives me an output for y of 1/2. Now let's go ahead and try to graph the arc function. Notice that my x and y will need to switch for the inverse function. So instead of labeling the x as negative pi over 2, that will become the labeling for the y-axis. Negative pi over 2 to positive pi over 2. And then negative 1 to 1 was for the y-axis. That will become the x-axis scale. Now we're going to graph point by point. So we're going to start. This point right here is x is negative pi over 2. So that will become y is negative pi over 2. This point here is 0, 0. This point is x is pi over 6. So this would be pi over 6. And the y was 1/2, so that will become the x value. And last 1 is pi over 2. Why don't we graph this value as well? This is negative pi over 6, negative 1/2. And there is the arc sine function. Notice the arc sine function is restricted in that it has endpoints, not an angle. It does not continue with an arrow. It has definite defined endpoints. Let's do the same thing with the cosine function. Here is the basic graph of my cosine function. And now I'm going to restrict the region for the cosine function so that it will pass the horizontal line test, so it will have an inverse. The restriction by definition, and this is always true, we are always going to restrict it between 0 and pi. So now let's go ahead and plot cos inverse x. So here we had our x was between 0 and pi. So my y will be between 0 and pi. So I'll make this pi halves. And then my x will be between -1 and +1. So let's graph these 3 points first. -1 is pi. Pi over 2, 0. So 0 pi over 2. And then 1, 0, 1 becomes 1, 0. Now, I'd like to have at least one other value. So what I'm going to choose is this point right here, because this point is pi thirds. The cosine of pi thirds is 1/2. So if I would graph pi thirds, I know that that is going to correspond the cosine inverse of 1/2 is pi thirds. Why don't we also do 2 pi thirds? The inverse of -1/2 is 2 pi thirds. And now I can go ahead and graph the cos inverse function. Notice it has defined endpoints. It is always going to be defined for a range is going to be 0 to pi. Now let's graph the tangent function. The tangent function, you know, has asymptotes at every pi halves. And we can go ahead and graph that. Notice pi force. The tangent of pi force is 1. The tangent of negative pi force is -1. This one's pretty easy. We're going to restrict it to this section that's right here in the middle. That is right around the 0. So let's go ahead and graph. We notice on the tangent function, our x values for our restricted region are negative pi halves to pi halves with asymptotes at each end. So that is going to become the range for our arctan function. This pi halves, this is negative pi halves. And looks like we also have values at pi force and negative pi force. So we have a horizontal asymptote, and before we had vertical asymptotes. So let's also graph that this is 1, and this is, -1, and this is 1. Let's go ahead and graph our function. This point is negative pi force, -1. So this is -1, negative pi force. 0 and 0. If we have an input of pi force, an output of 1, a input of 1, an output of pi force. And then we can go ahead and graph the arctan function. So the arctan function has a range of negative pi over 2 to positive pi over 2. Let's do a few problems. First, let's do the arcsine of -1/2. Hopefully you remember from your unit circle that sine of 1/2 is pi 6. And then we know because this is negative, it has to be negative pi 6. That is because the range for the arc function, or the arcsine function, is going to be negative pi over 2 to positive pi over 2. So I have to choose negative pi over 6. Let's look at the cosine function, however. If I do the arc cos of -1/2, well, you know it relates with cosine, that it's going to be related to pi thirds. But we know that the range output for our arc cos is between 0 and pi. So we have to think of which value, and that would be like your quadrant 2 value, and so that would be 2 pi thirds, where cosine is negative. Let's do a third problem. Let's do the tangent. Actually, let's make this the arctangent of the tangent of 3 pi fourths. I start this problem by doing the inside operation. So first thing I'm going to do is figure out what the tangent of 3 pi fourths is. I know that that tangent is equal to -1. So then I come up with the arctan of -1. And then I have to think which value would this be, and this is going to be -pi fourths. That is because the range for the arctan is -pi/2 to +pi/2. One last problem, and this is one where we cannot find the exact value, and so we're going to use drawing a triangle to help us solve it. Let's do the arcsine of the cosine of x over x plus 1. Excuse me, let me stop that. I have that reversed. Let's do the cosine of the arcsine of x over x plus 1. Remember, the inputs for a arc function are trig ratios, and the output for the arc function is an angle. So let's go ahead and draw our triangle. This is our theta, and if we are doing the arcsine, we know it is the opposite would have been x, and this must have been the hypotenuse. Let's call the missing side b, and so x squared plus b squared is equal to x plus 1 squared. Going ahead and expanding this, x squared plus b squared equals x squared plus 2x plus 1. Subtracting x squared from each side yields b squared equals 2x plus 1. Let's take the square root. So b is the square root of 2x plus 1. And so we can now find our cosine function. The cos of theta is equal to the square root of 2x plus 1 divided by x plus 1. Thanks for listening.